So we're going to be looking at 6.1 first. 6.1 is about finding greatest common factors, and also towards the end we're going to be looking at factor by grouping. First thing they want us to do is find common factors for all these terms. The best idea here is to just set them up so you're stacking these all up above each other. And the whole idea is to find what is going to be in common with all of these, which is something that you're going to be doing a lot of your, with basically every problem here, and the future sections as well, is finding out what's in common with these terms. One thing you could always do, sorry, that's a B. One thing you can do is always make a factor tree. So I'm just going to do the factor trees in the first one just to remind you guys what the factor tree is, and we're just going to look at the number. You want to break it up to prime numbers. This breaks up to 2 and 63. 63 breaks up to 3 and 21. 21 breaks up to 7 and 3. You got your prime numbers right there. So you can rewrite 126 as 2 times 3 times 3 times 7. Then it looks like you have an A, and then you got 3 B's. So if you multiply all of this, you end up getting 126 AB to the third. Negative 210, once again you would do a factor tree, and I'm not going to repeat it because that's something you guys should know how to do. It's just a little review. That breaks up to 2 times 3 times 5 times 7 times A. Same thing with 462B. That breaks up to 2 times 3 times 7 times 11 times B. And then negative 294. And remember, when it's a negative, just pull out that negative 1 and then just prime factorize the 294. Now you prime factorize that, and you get 2 times 3 times 7 times 7 times A times B. So the greatest common factors. Basically, what's the same with all of them? Well, here we notice they all have a 2. We got 2, 2, 2, 2. So for starters, for the GCF, we could definitely pull a 2. And looks like they all have a 3, 3, 3, 3, 3. So you can pull out a 3. Here, they don't have another 3, but do they all have a 7? Yep. 7, 7, 7, 7. And then we also look at the variables. A here, A there, but no A. So you can ignore the A. B there, but no B, so no B. So that's it. You just multiply this out. 2 times 3 is 6. 6 times 7. So for this answer here, we find the greatest common factor to be 42, which means all of these will be divisible by 42. Next problem, what they want you to do is factor completely. And they start you off, they say, hey, within both of these, the GCF is 4s. So one thing that I want you to start doing here, you're going to notice this to be very useful, especially towards the end of this section, is they're basically telling you that this and that is divisible by 4s. Well, if we divide this by 4s, what do we get? We divide 16s squared by 4s. Remember, we're using the quotient rule, 2 minus 1, and we divide 16 divided by 4 is just 4. S squared divided by like s to the power 1, 2 minus 1, just get s. And you do negative 20 divided by 4 is negative 5, and the s's cancel. So what they're saying here is you can rewrite 16s squared minus 20s as 4s, open parentheses, 4s minus 5. All you did is factor out the GCF, and this will be the solution that you're just be putting inside the parentheses there. Something you're going to be doing a lot now is factoring out, finding the GCF. Here the GCF once again was 4s. Once again, they want you to do the same thing. Here, they're not starting you off though. The last problem they found the GCF. Here what you have to do is find the GCF yourself. and you're going to factor. You're going to be doing a lot of factoring from here on out, so it's very important that you understand how to factor. Here we're dealing with the fraction. The nice thing about both of these is they both have a denominator of 4. So what you'll say is you're going to say, definitely you're going to have a fraction. Your denominator will be 4. And then let's just look at the numerators. That's a prime number, that's a prime, so it'll only be 1. And now here you have d to the third and d to the second. And if we just look at that, that's d times d times d. That's d to the third. D to the second is d times d. And here we notice finding the GCF would be d times d, which is d squared, which you could also include there. So now all you're going to do, divide this by 1/4, d squared. Divide that by 1/4, d squared. We divide there, we get d. We divide here, we just get -3. So factored out, we get this as a solution. Once again, they want us to factor, and they say we could check as well. So we got 6x to the 4th minus 18x squared. And like I said, you're always going to start off by finding its GCF. So, and the more you do this, the better you're going to get with this. When we break this up, if you want, I'll show you the long way. 6 is just 2 times 3, and this is x, 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 x. 18 is 9 times 2, and we can break up 9 to 3 and 3, and we have 2 x's. So here we get our GCF to be, we see 2, we see 3, and then we're going to see x by 6x squared. It's going to be 6x squared. Well, once again, we divide both of those by 6x squared. And when we do that, 6 divided by 6 is just 1. We do the quotient rule again. 4 minus 2 at x squared. Negative 18 divided by 6 is negative 3. And our x's squared cancel. So we just factored that out. So once again, we're factoring. This time we have 3 terms. We're factoring a trinomial instead of binomial. So we're going to do the exact same thing again. Find our GCF. We have 28x to the third minus 21x squared plus 7x. So we're going to notice that we can divide all of these. Our GCF is going to just be 7x. So we're going to pull out a 7x, and we just divide. Remember, 7x is the GCF, which is the first thing you're going to be doing. 28 divided by 7 is just 3. And then you use the quotient rule. You do 3 minus 1 is x squared. You do 21 divided by 7. I'm sorry, 28 divided by... Let's start this over again. 28 divided by 7 is 4. You do the quotient rule. 3 minus 1 is x squared. 21 divided by 7 is negative 3. Quotient rule again. 2 minus 1 is just x. And 7x divided by 7x, you just get a 1. So here we just factored that out using finding our GCF first, which is 7x. Once again, they want you to factor. And here we notice that with both of these terms, what they both have in common is y minus 3. So that's exactly what we're going to pull out, is a y minus 3. And let's keep that in parentheses, keep it by itself. And what happens when you divide y minus 3? Those cancel, and you're just left with x. Here, the second part where you divide it by y minus 3, you just get a positive t. So what we just did there, once again, was factored out. Now here, the next part, they're going to want you factor by grouping. So factor by grouping is something new, but nonetheless, you've already been doing it. We're just going to look into it in a little bit more detail. What I want you to do, whenever it says factor by grouping, I just want you to throw a line right in the middle. You're going to find two GCFs. So let's start here. The GCF there, what do they both have in common? An M. So you're going to put an M in front. And what happens when you divide? This divided by 6m divided by m is just 6. A positive mn divided by m is just a positive n. Find GCF again here. You find it to be 3. And what kind of 3? A positive 3. That's going to go in the front. Once again, you divide. 18 divided by 3 is 6. A positive 3n divided by a positive 3 is just a positive n. The whole idea about factor by grouping, we see that this and that are the same, which is what you want. So what you're going to do is you're just going to write that one time in the parentheses. And then what are you left with? A m and a positive 3, which is going to go inside your other parentheses. Factor by grouping, I want you to put a line in the middle, and then find the GCF for the first part, find the GCF for the second part. The whole idea is to make those be the same. When they're the same, you write it one time. And then whatever you're left over with goes on your next parentheses. One more, we're looking at factor by grouping again. Once again, put a line down the middle and work with one part. Well, is there anything in common there? There is not. So when there's not, you could say it's just a 1. Pull out a 1, everything still stays inside. Here, you'll notice that you can pull out a 3 and an R. It's a positive 3R. And you're left with what? W minus T. But here you see a problem. There's nothing the same. So, one thing that I want you to understand is sometimes with factor by grouping, what you may have to do is move these two middle terms. Just rewrite them. Make sure the signs stay the same. You notice here, this 3WR was positive, it's still positive. This 9TW was negative, it's still negative. So now let's try it again. We see these both have a GCF of R, the first part, we pulled that out, we're just left with R plus 3W. Here, they're both negative, so I'm going to pull out a negative, looks like a 3T. Negative 3T. And once I divide there, I get a positive W, and I get a positive 3W and a positive R. Now I see that these both are the same. Alright, they're just rewritten. But nonetheless, they're the same. So I could write that in one parentheses, and whatever I'm left with will go in my other parentheses, R minus 3T. So 6.1, a very important section. We're learning how to find a GCF, then how to use a GCF to do factoring.